This is Chapter 3, Selections, Programming Exercise 1. Algebra, solve quadratic equations. Now, for this exercise, what we're going to do is we're going to write a program that prompts the user to enter values for A, B, and C and displays the result based on the discriminant. If the discriminant is positive, display two roots. If the discriminant is 0, display one root. Otherwise, display the equation has no real roots. Note, to solve for the discriminant, we have b squared minus 4 times a times c, which is called the discriminant of the quadratic equation. If the discriminant is positive, the equation has two real roots. If the discriminant is 0, the equation has one root. And if the discriminant is negative, the equation has no real values. So, how do we solve this? Well, we're actually given three formulas, right? Now, two of these formulas is to solve for the roots, root 1 and root 2, which is basically negative b plus b squared minus 4 times a times c, and you square root this whole thing right here, and then you divide that by 2 times a. And the only difference between root 1 and root 2 is that you add for root 1 minus for root 2. You could do it vice versa. Doesn't really matter as long as you make sure that you solve for the plus and the minus for these root 1 and root 2. And of course, you most likely have seen this before. And this is basically x equals negative b plus minus square root b squared minus 4 times a times c, divide the whole thing by 2a. So that's what this whole thing is, but we broke it into root 1 and root 2. And of course, determinant is b squared minus 4 times a times c, which is this right here to find the determinant. Now, how do we take this whole thing and how do we solve for it? Well, simply, first thing we're going to do is request for the three values, A, B, and C, right? A, B, and C right here. We have to request for that from the user before we could plug in and solve. So that's step 1. Step 2 is to basically, after we got A, B, and C, plug it into root 1 and root 2. So once we plug it in, we could solve for root 1 and root 2. Step 3, solve for the determinant, and the reason for that is because we want to find out the determinant is positive, 0, or negative, right? Determining on which or what value this determinant is, we're going to go into step 4 and use conditional statements to display the result based on the discriminant. I missed to display, that's what I meant right here, to display the results based on the discriminant. All right, so moving on to the next step. Basically, step 1. There are three things that we have here, three choices to display to test if our case work. Right here we're gonna, in this video or in these slides, we're just gonna work through A. But after we start the programming exercise, we're gonna try all three. So A should net us 2 roots. So a positive number, a number greater than 0, okay? And then we're going to test for case B and C later on. So how do we solve this, right? Moving on to step 2. Well, we're going to plug in the values and solve for it. So like before I said, we're going to just solve for A, which is 1.03 and 1, right? 1.3 and 1. 1.0 is going to be A, 3 is going to be B, and 1 is going to be C. We have the formula for root 1 and root 2. Root 1 is basically negative b and the square root of b squared minus 4 times a times c, and divide this whole thing by 2 times a. Same thing with root 2, but instead of plus, we do minus. Plug all of that in, where a right here is 1.0. B right here is 3. Right? For everything that's B, you plug in 3. And for everything that's C, you plug in 1. So C right here, you plug in 1. Okay? And then you solve for it, and here's what we got right here. So this is root 1, which is 0.381966, and root 2, which is negative 2.61803. All right. Now, next, we solve for the determinant. Now, determinant, same thing before. We're given the formula b squared minus 4 times a times c, and we take the same value a, b, and c, and we plug it in. We plug it in, and we find our determinant. And here comes the most important part of the exercise. We have to solve for if, right? Let's go all the way back. If the discriminant is positive, display 2 roots. If the discriminant is 0, display 1 root. If the discriminant is neither positive or 0, meaning negative, then display the equation has no real roots. So that leads us to 3 possible if cases that could happen. Now these cases, starting with case 1, is if the determinant is positive, then you could display both roots using the if keyword, using the determinant, and then using the operator right here to check if it's greater than 0, right? If a number is greater than 0, it is a number that's 1 and up. Therefore, it's a positive number. And if it's a positive number, then you could display root 1 and root 2. Now, the other case is if the determinant is 0, then display root 1. Or you could display root 2, but you only display 1 root. So, to do that, you use the if keyword. Inside these parentheses, you solve for this Boolean case. Boolean case as in a case that will return you a true or a false value. True or false. That's a Boolean case or scenario, right? And that's what this if statement takes in, true or false. Is it true that determinant is equal to 0? Does 5 equal 0, right? In the previous case, we got determinant is 5. No, 5 does not equal 0. Therefore, this if statement will not show, and it will continue on to the next. But what if it shows for this, right? If determinant is greater than 0, is 5 greater than 0? Yes, that is true. If it is true, then it will display this. All right, so now for our last case, if determinant is negative, then display a string. So if determinant is less than 0, if 5 is less than 0, then display the equation has no real roots. But is 5 less than 0? No, 5 is not less than 0. Therefore, it will not display this. So the only thing it will display is this right here. All right, so why don't we try tackling that in an actual exercise? All right. So right here, we're going to write all of that, and we're going to create a whole bunch of variables first. And they're all going to be double data type. Let's start with A, B, and C. Now this A, B, and C will be the variables we take in to plug into root 1 and 2. Of course, we're going to have root 1, root 2, and then of course determinant, because determinant is the one that will determine if we display no root, 1 root, or 2 roots. All right, so let's ask for A first. All right, so we could just simply say, actually, before I do that, let's see, right, scanner input equals new scanner, system dot in, and there we go, and we'll say system dot out dot print, enter the value for A. And then we'll say A equals input dot next, we'll just say next double. Okay, we're going to do this for A, B, and C. Let's space it out so it'll be easier to see. This will be B, and this will be C. All right, so now we got our values. Now let's see if we did it correctly. We'll print out A, B, and C. All right, I'm gonna run that. think we'll do 1.0, 3, and 1. There we go. We got 1.0, 3, and 1. The reason instead of it displaying just a 3 and it shows 3.0 and 1, it shows 1.0 is because we're saying this is a double value, right? So if it's a double value, it'll show as a double. So that's what you see right there. So now we got our A, B, and C. Now next, I should actually comment this right here. Get the values for A, B, and C. And next part is to solve for root 1 and root 2. Okay, so the easier way for me to do this is just look at it, all right? Because I don't remember the formula by heart, so I would have to look at this. Let me instead, I'll just drag it right here so I could, I'll just have to drag it to the side. Okay, there we go, that's fine enough. Basically, we'll say root 1 equals to negative b plus, and I'm gonna have to watch carefully how I write this, because we have to remember order of precedence means that Java will solve this according to who or which number or equations should be solved first. So we have to make sure we write this out correctly. If we don't, we're going to make a mistake and it's going to give us the wrong answer. Now right here, math.power basically means you could use, basically this is a function in the math class that allows you to write the power of, or performs the power for you. If you want a square, you want a cube, you want to do a larger number, you could write it, right? So in this case, I want a square. So you put in the number that you want to square. In this case, is b, and you put in 2. 2 to square, 3 to cube, 4 to, you know, I don't know what 4 is called after that, but yeah. And then you do minus 4 times a times c. Now here's the tricky part. You got to actually square root this whole entire thing, right? Remember, you gotta square root this whole entire thing. Square root b squared minus 4ac square root it. So to do that, we use a another math function. Math.sqrt, that stands for square root, and it only takes in one value. So it takes in this whole thing and it's going to square root it. Now, look at these parentheses. These order of parentheses matter. So before I say anything else, let me do this first. 2 times a. Okay. Now what happens? Let's take a look here. You'll see that this parentheses show that's wrapped up right here. It'll show that it'll perform this first within here, and this will be performed in here. So basically what I meant to say is any parentheses within, or the closest parentheses, or the, how do I say this? The midmost parentheses are the one that gets solved first. So if there's no other parentheses in here, it'll solve this one first. Then it'll solve the outer parentheses, right? So solve this one first, then it'll solve this one first, then it'll solve the outer parentheses, all right? And then it keeps going out, out, and outer. That's how that will work if you use parentheses. So if you are not sure if you are making it calculate in the order that you want to, you could use parentheses to make it more precise, all right? So basically it'll solve this whole thing first before it'll even divide by this, right? So it'll solve this, and then it'll solve this, and then it sees no other parentheses out here, and then it'll do a division, all right? So okay, that's that's all I'm gonna talk about for parentheses. I don't want to go too much and then end up repeating the same thing over. Now, like I said before, Root 1 and root 2, the only difference is this plus and this minus. So make sure you do that. And now you get two different values. So let's take a look at what we got here to see if I did this correctly, right? Do a system.out.print root 1 plus space plus root 2. Now in my little slide here, I have what did I get? I plug in 1.031 and I get 0.381966 for root 1, and root 2 I get 2.61803. So let's double check my math or my my formula right here. So let's run that, and we'll get 1, 3 for B and 1 for C, and there you go. So we got negative 0.38 did I do this correctly? Positive 0.38 plus square root plus that. Yeah, it should be, I think I forgot to put a negative here. So it should be a negative and negative 2.61803. Negative 2.61. Yeah, so okay, so let me just double check. Plus negative negative. Let me double check my yeah, that should be it. Yeah, I think I just probably forgot to write a negative in here. No, did I? Let's see. Divided by, okay, square root. So that's like a really small number. Yeah, let me double check. All right, so let me just do one quick check and I can confirm. Math.square root of 5. Run that. 131, and I get a positive. So basically I'm trying to say 2.2. So oops. Oh man, where am I? Okay, basically negative 3 plus 2.2, so that is about 0.7. Yeah, it's a negative. All right, okay, so math is correct over here. Okay, everything's all good. Oh man, I should double check. All right. Okay, so we solve for root 1 and root 2. Now, the next thing we gotta solve for is solve for the determinant. And of course, we are given the formula. Determinant is basically equals this right here. Is it just this right here? Basically, where does this go? Okay, this right here. All right, now to make sure I did that correctly, system.out. I don't want to keep writing A, B, and C. So what I'm going to do is do Control Shift slash or forward slash to comment this part out. And I'm going to say A equals 1, B equals 3, C equals 1, right? System dot print system dot out dot print determinant. All right, and let's run that. Now if I got a 5, then that's exactly what I did or what I got when I calculate over here, right? Plug that in. Basically B is 3, 3 squared is 9, and plug that in. 4 times 1 times 1 is 4, so 9 minus 4 is 5, and that's exactly what we got over here, 5. Okay, so we got that. Basically, exactly what we expected. And finally, solve for display the roots depending on the determinants. Now here is of course what we came for. What is the what we have learned in chapter 3, the if case, right? The operators, the if statement, the switch, but we're not going to be using the switch case right here. We'll just be learning about the if. Now remember, we have 3 possibilities. They are basically if the determinant is positive, or if it's greater than 0, then display root 1 and root 2. I'm going to start with that. Let's see. Simply say if, right? Like I said, if determinant is greater than 0, right? Simple like that. Simply, it just says if keyword, and then you follow by parentheses. Inside that parentheses, it's going to solve for a true or false operation. If it's true, then it will display. If it's false, nothing, it won't display anything, or it won't run anything. It won't it will ignore the following step. And this is a step that we're going to write. Now, to make it clear, you should always put a parentheses right here, so that way you know what will happen in here. If you don't put parentheses in here, it will just run the next line, and it won't, and then as part of the if, and ignore the rest, pretending it's not part of the if, and continue reading it, right? Hopefully, actually that, I should say, if you don't put a parentheses, it's just going to read one line right after the if statement, and it won't, and then it'll continue doing what it needs to do. So let me actually show you a better example. So I'll say if determinant is greater than 0, system.out.println, I'll say it is greater than 0. Actually, I'll just display it to root 1, root 2. Root 1 plus comma root 2. And then I'll say system.out.print. This should have been part of the if statement. So actually, let me say, so right now we know that determinant is 5, right? So since this is 5, it'll display this, and it'll display this, which makes sense, right? So it'll display the root, and then it'll display this should have been part of the if statement. Now, what happened if I say if determinant is less than 0? Well, I'm going to run that, and it turns out if 5 is less than 0, it won't even display this at all, and it'll continue on to the next line. And the next line is this if statement right here, which is what gets displayed. Now, if we put this inside a parentheses, what happens is that nothing gets displayed, right? You see nothing at all. So it knows to ignore to display any of this. If this is true, then display this. If this is false, don't display any of this and go on to the next line after this, what's this, curly brace, right? So that's why it is recommended to use this curly brace. Even if you only have one line of code, still use it. That way you don't mess up if you're trying to do something or write a little more and have it part of the if statement and you forgot to put the curly braces, you're going to cause a lot of confusion in your code. Now, next thing is if determinant is equal to 0, all right, and this right here does not mean equal, it means assignment. what I'm doing right here is actually assigning 0 to determinant. So I make this determinant now equals 0 when it was equals 5. To actually do a comparison, you have to do 2 equal signs. This double equal signs allow Java to know, oh, okay, you're actually doing a comparison right here, and you're not trying to assign a value like I did right here. I'm trying to assign 1 to A. I'm not trying to compare it, which is double equal sign. I'm trying to assign the value 1 to A. In this case, I'm comparing determinant to the value 0. So if determinant is equals to 0, then I want to just display root 1. And then lastly, if determinant is less than 0, so it means it's a negative number, then I'll just say system.out.print line there are no roots. All right, bam, I am done. So let's do a run of that. And what do we get? We get just one thing. We get that it displays the root, 2 roots in fact. Therefore, we know that determinant is greater than 0. So what happened is that, let's start from the top. I assign the value 1 to A, 3 to B, 1 to C, root 1, root 2, and determinant is variables that I will solve for. And I solve for by plugging in the formula right here for root 1 and plugging in this formula right here for root 2. Now, to solve for determinant, which will allow me to decide whether I display both root, 1 root, or no roots, is with this formula right here. I take that determinant and use an if statement. If statement is followed by parentheses, and within the parentheses, you put in a value that you want it to compare. Now this value in here always have to return a true or false. That's what it takes in. If the value right here returns true, then it will display everything in here. If the value in here is false, it will not display anything in here, and the code will continue on right after this parentheses, and it'll jump straight to the next if statement. And then if the next if statement is if determinant equals 0, if this is true, then display. If this is false, go to jump after this curly brace to continue on to the next code. If determinant is less than 0, if it's true, display. If false, don't display. So there are other cases that could happen. If none of this is true, then nothing will display. If all of this is true, then all of this will be printed out. All right. So you could make sure that your if statement is written out correctly. And if you only want one thing to display, right, there is a possibility that if all of it's true, but you only want to display the first one, then you use if, and then else if, and lastly else. And I'll go more into that in later exercise. Okay, I don't want to confuse you too much with that right now. For now, we managed to display 2 roots. What about another one where we have B, 1, 2, and 1? So we'll just plug in right here, 1, 2, and 1. And when we run that, how many roots do we see? Well, we only see 1 root. Well, let's find that. Let's find out why. System.out.print the determinant is determinant. So we run that again. And we find out that determinant is 0. So if determinant equals 0, display only 1 root, and it did exactly that. Lastly, 1, 2, and 3. When we run that, we get determinant is -8. So therefore, It is not greater than 0. It does not equal 0, but it is less than 0. And if it's less than 0, display no roots. Display that there are no roots. All right. So hopefully that makes sense, and that helps you understand the if statement a little bit better. And that'll be it for this exercise.